Now that we have calculated the total sums of squares, the sums of squares due to hospitals, and the sums of squares within hospitals, we can move to the completion of the analysis of variance. The next step in the completion of the analysis of variance is to fill in the degrees of freedom for each of the three separate categories. The total degrees of freedom is 1 minus the total number of observations. Since there are 4 hospitals and 30 admissions to each hospital, the total degrees of freedom will be 4 times 30 minus 1, or 119. There are 4 hospitals and 4 minus 1 degrees of freedom, so there are 3 degrees of freedom for hospitals. And within hospitals, there are degrees of freedom equal to the number of degrees of freedom that would exist for each of the hospitals times the number of hospitals. Within each hospital there are 30 observations. So there are 30 minus 1 observations or degrees of freedom in each hospital times 4 hospitals, or 116 degrees of freedom. It's easy to see that the degrees of freedom for hospitals and the degrees of freedom within hospitals is equal to the total degrees of freedom, as it should be. The next step is to calculate the mean square values for hospitals and within hospitals. The mean square is the average sums of squares per degree of freedom and is the value that is used in the calculation of the F-test. So for the mean square for hospitals, I will divide the sums of squares by degrees of freedom, and I will drag the lower right hand corner of cell I4 down to I5, and I now have the mean square, or the average number of, or the average sums of squares across degrees of freedom for within hospitals. Now the F-test is carried out by dividing the mean square for hospitals by the mean square within hospitals, and the F value is 3.73 and a number of additional decimal points. The final step in the analysis of variance to this point is to find the probability of an F value as large as 3.73 under the null hypothesis that cost is independent of hospitals. In order to do that, we'll use the F-dist function, which will give us the probability of an F value as large as 3.73. F-dist takes 3 arguments. The first is the F value itself, then a comma. The second is degrees of freedom in the numerator, which is the degrees of freedom for hospitals. And the third is the degrees of freedom in the denominator. And when I hit enter, I see that the probability is 0.013. So the probability of getting an F value as large as 3.73 under the null hypothesis that cost is independent of hospitals is very small, almost 1 in 100. With a probability that small, we would conclude that we must reject the null hypothesis, and having rejected the null hypothesis of independence, we will accept the alternative, which says that hospital cost is not independent of hospitals. In other words, the hospital that you go to will determine the cost of that stay.